Hi there, I want to help you get started on your 2-gram challenge. I'm going to do this problem for you using the mole map. This is the problem that we did in class. I kind of broke it down where I'm not showing the products here to hopefully help you with the 2-gram challenge. Let's take a look at that real quick. Your goal is to figure out how you're going to get 2 grams of precipitate. A precipitate is that fancy word for means a solid. You're making a solid in this one. And that you'll see right up here. So here I tell you about the 2 different substances you've got. Everybody's got 2 different reactants. And one is a solid, and one is a solution, an aqueous thing. And you're going to be doing a double replacement reaction. In other words, you're going to create 2 different products here. And then you have to decide which of these products is actually your solid. A little hint on how to look for that. It's on the back of your periodic table. This is the solubility rules. And solubility means, soluble means it dissolves in water. Not soluble means it does not dissolve in water. So this is a chart we used before to figure out which ones were solid and which ones weren't. And when we were deciding how do I predict the products, I use this bottom part down here, these polyatomic ions, because each of you has a polyatomic ion in one of your reactants or both reactants. Okay, so let me kind of show you here. This one here in my example problem is the one we did in class, and you already have the products for that, but I'm going to show you how I would predict those. So this one here is a single replacement. Now in your lab, you're doing a double replacement. So double would be just a double switcheroo. Here I'm going to show you a single switcheroo. In other words, I've got magnesium, a single guy, and he's going to replace some part of my HCl. I'm going to chop my HCl in half. When you do replacement, you want to find what's positive and what's negative. Here's my H, and he's a 1+. I know that because if I look on the periodic table, he's in that very first column. H is a 1+ charge. Chlorine is a 1- charge. He's in that second to right column on your periodic table, which means he likes to gain 1 electron, and that's why he's a 1-. That's something we also covered at the beginning of the year. Now magnesium here, if he's going to have a charge, he's in the second column from the left, so he's going to have a +2 charge. So in other words, if he's going to connect with something on the other side here, he's going to want to connect with something that's opposite in charge, the chlorine. So now I've got magnesium, he's a 2+, and my chlorine, he's a 1-. Now 2+ and 1-, that's not so happy together, but if we put a little 2 down here, now suddenly I have 2 chlorines, each worth a 1-. 2+ will balance out the 2- that these have total, and then it's a happy, balanced sort of compound. The charge is balanced. The number of electrons lost were 2. The number of electrons gained were 2 also. That works out. Plus, on the other side, I've got just plain old hydrogen. Now, hydrogen is one of those Hofbränkels. In other words, he's a diatomic molecule. Never find him by himself, which is why I'm putting the 2 there. Now I've predicted my products. That's step 1. Same thing for you. That's your step 1. Now I need to balance the equation. That means I've got to put these numbers out in front here. In order to have all the number of atoms on the left be exactly the same as the number of atoms on the right-hand side. Right here on the left side, I've got 1 magnesium, and on the right, I've got 1 magnesium. That's good. On the left, I've got 1 hydrogen, but on the right, I've got 2 hydrogens. So it's like I created something from nothing. Only God can do that. So I've got to put in a 2 right here out front. That way I've got 2 hydrogens to balance out the 2 hydrogens on the right. Now if I check out my chlorines, that 2 also applies to my chlorines there. So I've got 2 chlorines on the left, 2 chlorines on the right. Everything is looking pretty good. That is kind of step 1 for you. Now you're going to have to do that with a double replacement reaction. So I did a single, you've got the double. It's very similar though. Okay. The next step in your 2-gram challenge is to do some stoich. Stoichiometry is that fancy word for do a bunch of fancy math in order to figure out how many grams that you're going to need to put in order to get 2 grams out. Now I'm going to do this problem to kind of show you how to do that, but I'm doing it opposite. We did this problem in class, but the question is kind of similar. It says to me here there's 2 liters of 6 molar HCl. That means this stuff, I've got 2 liters of it and it's 6.0 molar. And then it tells me I have 500 grams of magnesium. 500 grams of this. How many grams of hydrogen can be produced? That's my question part. Okay, so I'm going to say to myself, okay, I want to know how much hydrogen is going to be made. Well, for that, question mark, grams of hydrogen. That's the part I want to find. It says how many grams of hydrogen do I have? Question mark, grams of hydrogen are equal to, now notice I've got 2 different reactants, so I really have to ask this 2 times. And on the other side of the equal sign is going to be those two problems. In other words, 500 grams of magnesium. And the other one is I have to start with something of hydrochloric acid, the HCl. Now I'll get back to this one, but let's stick with the magnesium here. Now I have to ask myself two problems because it's kind of like you have a jar of peanut butter, 6 pieces of bread, and 2 spoonfuls of jam. And you ask yourself, how many sandwiches can you make of peanut butter and jelly sandwiches? Well, in order to answer that question, you would look at, okay, I got 6 pieces of bread, so that means I can make 3 sandwiches. From a jar of peanut butter, I can make a lot. But from a scoop of jam, I'm only going to be able to make 1 sandwich from that. So you ask yourself, how many sandwiches could you make from each of the reactants? This is the same kind of deal. I'm asking myself, how much hydrogen can I make from each of my reactants? So I've got 2 problems because I got 2 different amounts. So let's start with this 500 grams of magnesium. Now taking a look at the mole map here, I am in grams of magnesium. That means I'm starting right here. And I'm trying to end with grams of hydrogen. So my ending spot is over here. So on the mole map, I'm going to go 1, 2, 3. It's going to take me 3 steps. Remember, all the stuff on the purple here is representing one type of compound. In this case, my purple I'm going to call magnesium. All the green over here represents the other compound. The green that I'm representing is hydrogen. So let's start with my magnesium here. I happen to have grams of magnesium on top. In order to get rid of that, I always want to put those units on the bottom. Grams of magnesium on the bottom. That way they cancel. And now I say to myself, okay, my first step is to leave grams. I just cancel those out. And go into moles. Moles of that same substance. So I'll put moles of Mg on top. Same substance. Now I look at the numbers. That's this part down here. 1 goes with mole. And grams is that periodic table number. That's the atomic mass in the periodic table. If you look for magnesium, he says 24.305. If you're using the periodic table I gave you, that's what it'll say on there. If you use a different periodic table on the computer, it might just say 24.3 or a different number of sig figs, like 24.31. It'll be about that. All right, now I'm going to multiply by another fraction because I've got moles of magnesium and I don't want that. So I'll put that on the bottom, moles of magnesium. That way I can get rid of them. I'm doing step 2 right here. I just left moles of magnesium, got that done, and I'm going into moles of a different substance. Moles of a different substance. Here the substance I care about is hydrogen, so moles of hydrogen on top. Now I'm going to be doing these for the numbers. I'm going to use the coefficients in the balanced equation. The coefficients are these front numbers up here. So my hydrogen has a 1. My magnesium has a 1 also. Last step, I've got to get out of moles of hydrogen, put it on the bottom, that way it cancels. And it's my last step here to go from moles to grams. Grams of hydrogen. Again, here's my conversion factor right here. 1 goes with mole, and grams is your periodic table number. So if you look in the periodic table, you see hydrogen is worth 1.0079. And so I'm going to do 2 times the 1.0079 to add those together. 2 hydrogens. And at this point, I just got to push buttons in my calculator. My calculator said 41.55. Or looking at proper sig figs, it'd be about 40. I'll just keep it at 41.55 here. That's how many grams of hydrogen I can make from my 500 grams of magnesium. All right, I got half of the problem done. Moving to the second part. This here is a solution. Notice I had a solid for magnesium, and now I'm looking at a solution. Solution is what that aqueous means. So I'm going to relook at where I'm starting and where I'm ending. This mole map is like a map of a mall. It tells you where you are and where you need to go. So that's the first place you want to check. So I'm going to say to myself, I need to figure out where I want to start. Now they give me 2 different numbers about HCl. I got a liters and a molarity. Just like at a mall, you can have to start at a store. In other words, you have to start in one of the boxes. There is no box for molarity, so I must start in the liter spot. My options are liters or molarity, the big M. I've got to start in liters. Here's my starting spot. And it already told me I want to end in the same spot, my grams over here of hydrogen. Okay, well that lets me start out now. So on the other side of this, I'm going to start with 2 liters of HCl. Just like before, I plan out my map. I'm going to go up over and over. It's going to take me 3 fractions again. My first step is to get out of liters and into moles of the same purple stuff. Purple stuff here I'm calling is HCl now. So let's get out of liters of HCl and into moles of HCl. I put liters on the bottom, that way they canceled. And I'm going into moles, and to do that part, that's where I'm going to use molarity, because molarity equals moles per liter. In other words, this big M right here, it's defined as molarity, and molarity by definition means moles per liter. So from that, I know there are 6 moles in 1 liter. That's what this conversion tells me. Now I want to get out of moles of HCl, so I'll put that on the bottom. That way it'll cancel. And I'm trying to do my second step. I'm going into moles of my different substance. My different substance here is my green stuff, which is my hydrogen. So I'll put moles of hydrogen on top. Just like before, I want to use the coefficient in the balanced equation. In other words, hydrogen here is that 1, and HCl happens to have that 2 there. So I'll put the 2 in. My last step is right here on the mole map. I'm trying to get out of moles and into grams. And this is of hydrogen. So I'll put moles of hydrogen on the bottom. That way they'll cancel. Grams of hydrogen on top. And to do that, my conversion factor there is that 1 mole, 1 with mole, and the grams is the gram number from the periodic table, that atomic mass. I have 2 hydrogens, and each hydrogen on the periodic table is worth 1.0079. So this I push buttons in my calculator again. And I got 1212. So then I asked myself, okay, so I've got 1212 grams and 41.55 grams. It's kind of like that peanut butter and jelly example. From the bread, I can make 3 sandwiches. From the peanut butter, I can make like 100. From the jam, though, I could only make 1 sandwich. So the question is, how many sandwiches would you actually make? I would make 1 sandwich. So this is that same idea. I could make 41 sandwiches, or I could make 12 sandwiches. How many sandwiches will I really make? I'll make 12 sandwiches. Or in other words, 12 grams. 12.12 grams. And that's because my HCl is my limiting reactant. It ran out. And so after I made 12 grams, I don't have any more of this left to make anything else. So that's the stoic part of things. So in your question here, if we go back to this, the problem says, I want to make something, it's got to be a solid. I'll say this one's my solid. And the thing is, I want to make 2 grams of this. So the question you have to ask yourself is, how much of this do I want to put in? And how much of this do I want to put in order to get 2 grams out? Now, I did tell you the molarity of your solution. A lot of them is around 1, like 1.0 or 1.05, something around 1 molar. But I didn't tell you how many liters. So your real question is, how many liters of this aqueous solution and how many grams of this substance do I need to have? It's very similar to this problem here. It's just that you already know you want to make 2 grams. So it's kind of like you know the ending spot. You just don't know your beginning spot here. So you're going to do 2 math problems. Both of them start with question mark, and then you got to ask yourself, question mark this one, and the second problem is question mark this one. I hope that helps out a little bit.